Summary. Yes, AI is deeply rooted in statistics. In fact, you can think of machine learning as the modern name for applied statistical modeling, enhanced by computing power and algorithms. The origin, regression in biology. The term regression comes from the work of Sir Francis Galton, a 19th century polymath and cousin of Charles Darwin. In the late 1800s, Galton studied the relationship between the height of parents and their children. He noticed something surprising. Tall parents tended to have tall children, but not as tall. Short parents tended to have short children, but not as short. This pattern led him to coin the term regression toward mediocrity, now known as regression toward the mean. What Galton found: children's heights tended to regress toward the average, mean height of the population. That is, extreme traits in parents, very tall or short, were less extreme in their children. He developed the first form of regression analysis to mathematically describe this relationship. Why does this happen? Statistical plus biological explanation. Traits like height are influenced by both genetics and environment. If someone is extremely tall, it's likely due to a mix of genetic luck and favorable conditions. Their children inherit only part of that advantage, and random variation pulls their traits closer to the average. This is a universal statistical principle. When performance is partly random, extreme outcomes tend to be followed by less extreme ones, purely by chance. Modern regression. Galton's work laid the groundwork for linear regression, correlation, heritability analysis, and the general idea of predicting one variable from another using data. Summary. Yes, regression analysis literally began with the study of human height in biology. Galton observed that height regressed to the mean, and from that insight, the entire field of statistical regression was born. This chart shows a simulated version of Francis Galton's original data on parent versus child heights, which led to the discovery of regression. What you're seeing, blue dots, each point is a parent-child pair. Red dashed line, y equals x, if children exactly inherited their parents' height with no variation. Green line, the actual regression line, showing that children of tall parents tend to be tall, but closer to the average, and vice versa. This is the regression to the mean, Galton observed, and it became the foundation of modern statistical regression. The creator of AI isn't a single person. It's the result of contributions by many researchers over decades. But here are some of the most important figures and milestones. Foundational figures in AI. Alan Turing, often called the father of computer science. In the 1950s, he posed the question, can machines think, and created the Turing test. John McCarthy coined the term artificial intelligence in 1956 and organized the famous Dartmouth Conference, which launched AI as a field. Marvin Minsky, co-founder of the MIT AI Lab and a pioneer in AI research. Alan Newell and Herbert Simon created some of the first AI programs, like the logic theorist, and developed early theories of problem solving and reasoning. Modern AI breakthroughs. Geoffrey Hinton, Yann LeCun, and Yoshua Bengio, known as the godfathers of deep learning, they helped develop the neural networks that power today's AI like ChatGPT, image recognition, and speech systems. Elon Musk and Sam Altman co-founded OpenAI, the organization behind ChatGPT. Demis Hassabis, CEO of DeepMind, a Google-owned company that developed AI systems like AlphaGo. In short, AI was not created by one person, but evolved through the work of many brilliant scientists, engineers, and organizations over 70+ years. AI has deep roots in statistics. Here's a breakdown of how statistics has shaped modern AI. Statistics and AI, how they're connected. 1. Machine learning equals statistics algorithms. Machine learning, one of the core fields of AI, is fundamentally about making predictions or decisions from data. At its core, that process, estimating probabilities, identifying patterns, and quantifying uncertainty. 2. Key statistical concepts in AI. Regression and classification, fundamental supervised learning tasks based on statistical modeling. Bayesian inference, used in probabilistic models, robotics, natural language processing. Maximum likelihood estimation, MLE, a key statistical method used to train AI models. Markov models, foundation for models like hidden Markov models, HMM, used in speech and time series tasks. Sampling methods, Monte Carlo methods, used for probabilistic reasoning and generative AI. Deep learning also uses statistics. Neural networks optimize functions like cross-entropy loss, which is based on probability theory. Backpropagation and gradient descent rely on calculus and linear algebra, but the loss functions often come from statistical modeling. Why it matters. Statistical thinking helps AI systems understand uncertainty, generalize from data, avoid overfitting, make predictions with confidence intervals.